Today I'd like to talk about how it is we actually get a lot of information about stars, because scientists will often list off a lot of things that we know about stars, their temperature, what they're made of, things like that. But a question I've had a lot of times is, if you can't actually go there, how do you really know what you're saying is correct? And it's a very fair question. So the answer to that is that light that comes from stars gives us an awful lot of information about the star itself. The first thing that we're going to talk about that we can find from the light is the chemical composition. So what elements are making up that star? So the way that we can find this out is we look at something called the spectra. And what that is we take the light and we put it through a prism and we split it up into all the available wavelengths. And what that means in terms of visible light, it would be you split it up into every shade of every colour that there is. And outside of the visible spectrum, it is essentially the same thing, except they're not colours because our eyes can't see them. So when we're looking at a spectra, and we have all the available wavelengths in front of us, some of them will be missing. And that's because each individual element absorbs different specific wavelengths. So let's say hydrogen, for example, let's just make it up and say it absorbs 100, 200 and 300 nanometers. That is 3 different wavelengths of light. So if we're to take a spectrum after we've passed some light only through some hydrogen, if we split up at the end, we'll see a nice full spectrum, except there'd be 3 specific lines where the light isn't there, it's missing, we'd have little black lines. And that's exactly the principle used when we're looking at stars. So from laboratory experiments, we put a full spectrum, or as much as we need, through something that's gaseous, say hydrogen gas for example, and then we measure the light that comes out the other side after we've split it into this spectra, and we create a fingerprint for that element. And then over time we've done that with all the known elements so that we can identify them if we see the light coming from a star. So while it's a bit more complicated, the light that's actually come from a star, because there'll be all sorts of lines missing because there's all kinds of elements in there, the fingerprint is always exactly the same, and they don't really share the same wavelengths. Some will, or more likely they share wavelengths that are incredibly close together, so you might get a thick black line instead of a very defined thin black line. But given a bit of interpretation, just from those lines we see from the spectra, we can work out exactly what is present in the star. So the light's produced inside the star, it goes out through all the material that is making up the star, and then because space is a vacuum, doesn't really get in the way of anything before it gets to us, and then we measure it, look at the lines, pick out the specific fingerprints we know, and then we know what elements are there. Something else that you can find from just looking at the light that comes from a star is its temperature. So there's 2 different ways you can do this. One is a bit more obvious than the others. So the more obvious one is you would take the intensity of each light, so how much of that light are you getting, and you plot that against what the wavelength is, or the colour. And from that you'll get a nice curve shaped like a bell, and the peak position tells you how hot that star is, because that peak position is essentially the average energy coming out of that star. And depending on what the average energy of the light is, the higher or lower the temperature would be. Obviously a hotter star would have a higher average energy, and a colder star would have a lower average energy. So the other way you can sort of interpret temperature is by looking at the chemical composition that we talked about earlier. Now, it's a lot more vague because you can only have sort of guesses of what the temperature would be just by using this other method. However, it's a lot quicker to work out. So you would look at the chemical composition coming out of the star, go, well, I've got these elements. So we know as stars get older, they start to fuse heavier and heavier elements. So if we're looking at a star that has a lot of heavy elements in it, we know that the star's getting older, therefore we know it's getting colder, because that's another thing that we know. And then we can sort of have a vague guess of what the temperature would be. Obviously, if you wanted to know a certain temperature, you would use some other methods or some other maths. Something else you can find from looking at the light from a star is, again, we use the chemical composition, and we can work out how old the star is, or somewhere around how old the star is. And that's by, as mentioned, we use what elements are currently present in that star. We know the older the star is, the heavier the elements that are in the star, and therefore, depending on how heavy the elements have gotten within the star, all the way up to iron, we can have a guess about how old it is. And one final thing that you can find by looking at the light of a star is we can find if there's any exoplanets around it. Not all of the exoplanets that surround it, but ones where we're lucky enough to line up with the star and the exoplanet. So the way you would do this is you would just stare at it and wait to see if there is a drop in light intensity, because if there is, we know something that's gone in front of it isn't producing light. i.e. a planet. So you would measure how much of each of the light you were getting, and then wait for a significant drop in any or all of them, and then from that you know that something big has to have passed in front of the star. So that's a brief overview of how we learn some of the information we have about stars. Thank you for watching.